has its limitations, right? So I would say for me, this is kind of one of the areas that this area right here talks about the three forms, right? That you've got general, you've got vertex, and factored form. We haven't talked about the factored form yet, so this is the time that I do talk about it. You're not going to see that a whole lot. That's why I don't worry about it too much. But when you have two brackets, do you remember factoring in intro? Remember getting a trinomial and then you would rewrite it in this format? You were factoring. What you were doing is you were finding the x-intercepts. Okay? These numbers represent your x-intercepts. So you change the sign of both of these before you write them out. And I always have an example. So if you ever have x plus 5, x minus 4, guess what? Those are your x-intercepts right there. And if you miss that, I'm telling you already, if you miss that, just use your calculator and find them, and you're going to realize, oh, wait a minute, I could have saved myself some time figuring out that those are my x-intercepts, okay? But the first two I have talked about. Okay, so there's my vertex form. The vertex, in general, A tells me which way it's opening, if it's positive or negative. It also tells me that it's narrow, normal, or wide. So I include that in my diagram. Let me zoom in a little bit. Okay. I have made a note that B does a little bit of a side shift. So if B is positive, your curve is kind of going to shift over there. If it's negative, it's going to shift over there. So imagine Desmos going back and forth here, sliding the B value back and forth. And yes, it's counterintuitive. Negative shifts it to the right. A B, if it's positive and you increase it, it shifts it to the left. And what does C do? Look, I have C going down the arrow here. That's this bag right here. Vertical shift. So it gives me the y-intercept and it produces a vertical shift if I change the C values. Okay? So if you want to take a pic, let's see here. Let's see what B does. Okay, I think I'm just going to be the one sliding. Why is nothing happening? Oh yeah, it doesn't do a whole lot because I'm zoomed out too much. Okay, let's try it again. There's not much movement because I don't have a whole lot to slide back and forth. So let me change this to -20 and positive 20. Okay, so B is not that critical to know what it does because it doesn't give us a specific point, but I think it is cool to know, right? If B is negative, it's gonna it's like cradling a baby, right? That's what it kind of does. So it goes back and forth like that. That's what B does. I don't expect you to change the value of B ever. I don't expect you to know, oh, B is 5. What would it tell us? It doesn't tell us a whole lot, so we don't focus on it too much. But C, come on. C is important, okay? Watch what C, I'm going to slide it myself here. So C moves the parabola up or down, okay? You can't see that very clearly. Let me change the value of C also to -20. Isn't this like, you remember this is kind of like how we state domain and range, right? It's in between two values. Let's try that again, right? So if you were to change the values of C, it shifts it up or down. Okay, yes, Mr. Dixon, isn't it my y-intercept? Yeah, the actual value of C is my y-intercept when it's in general form. But changing the value of C if you were to increase it, it would shift the whole thing up or down, okay? Let's make a, let's turn this into a word problem here. Look what I've done. So let's imagine we start at a height of 20, we throw a ball up into the air, it reaches the maximum, and then it hits the ground there, okay? So that's kind of what we're gonna start looking at today. And so what if I said, hey, make me an equation, create an equation for me of a scenario where the ball reaches a higher maximum altitude. It's like, what would you do? What would be the first thing you should be thinking of? Or let's go lower, because I can't go higher right now. I maxed out on my C. But if you just decrease C ever so slightly, now the height of the ball of that new scenario is not going to reach, it was 50 something earlier, now it's 43, right? So shifting C up and down, that's the one I do want you to know about, okay? And I also want you to remember what A does. A tells us the direction of opening, and it makes it either steeper or wide. If you're between 0 and 1, right, if the value is between 0 and 1, it now becomes a really wide curve. Keeps opening up until I get to the 1, until I get to 1, that would be our, 1 is our normal curve, right there, okay? So we'll keep that in mind. Also, one more thing. If B is 0, watch what happens if B is 0. I want to emphasize that today because sometimes you'll have that. B is now set to 0. Where is the vertex at? Let me zoom out a bit. Can you see that it's like right dead center? Right? Like the y-axis is kind of like my axis of symmetry here. That is something that you will observe. If B is equal to 0, if it's not there, in other words, this part, like you're not going to even see an x in your equation. You know B is equal to 0. You have this case. It doesn't matter what C is. It doesn't matter what A is. It will stay right dead center. Right? That's something kind of neat to observe. If you don't observe that, you will see it when you graph it on your calculator. What I want to accomplish is that you know ahead of time what to expect. Okay? It's like when you're starting to drive. If you kind of know how to get there, you already know, oh, there's going to be a pothole in this corner. There's always someone turning left in this at this traffic light. So I will already kind of anticipate. I will know what to do ahead of time, right? I will know what to expect. So that's kind of why I want you to not just type it in blindly, but to know what's happening. Because if you make a mistake in typing it in, I want you to realize, wait a minute, A is positive. Why is it pointing down? I want you to be able to troubleshoot, be like, something went wrong. Something isn't right. Okay? Fun stuff. So, this is my study sheet. Another area I would like to, I have what I need for graphing, so I will kind of give that just a little, this is what I need always in it. To be honest, that takes up way too much room. In my opinion, that should not take, but I just remind myself, for graphing, I need labels, scale, and a shape, the appropriate shape. Just a reminder. That's going to go with you into grade 12, right? I'm just starting right now quadratics. Quadratics is part of it in grade 12 applied. Just starting it today, actually. Next, the next area that I think is important is domain and range. This region right here talks about domain and range, okay? So if you notice, I have scenarios here. It's a little messy, I know. I'm not too proud of this one. Like, I would sit down and make another one. But this is, I've been asked to give you a bit of an idea what to include, and this is it. So I've got scenarios with a graph, and then I state the domain and range in set and interval notation. So I've got like 3 here, and this is the more challenging one. This is the one we did last class where it has a start and a stop. There's no arrowhead. So this is a little different, okay? This is a little different. Last but not least, and take this with you to grade 12, okay? Don't discard the study sheet. And last but not least, I tell myself how to use the calculator. I'm going to use second trace. I remind myself what x-intercepts are, what y-intercepts are. Maybe you need one of these. X-intercept will always be a number followed by 0, right? A number followed by 0. The y-intercept will always be 0 followed by a number. Okay, that's maybe something you need to remind yourself. If you want to use value, if you want to find the y-intercept, we let x equal to 0, right? Second trace value, x equal to 0, y-intercept. Or, this is new for today, okay? Or, if you're given an x value, any x value that I throw at you, you will be able to find out the y value. That's what this function does as well. Second trace min or max, they find the vertex, and I have a little diagram there to help me understand which one to use when. Second trace intersect, it finds the x-intercept, or it will also find you the x value if you know the y value. This is new. We're going to use value and intersect quite a bit, okay? And so this is your calculator usage. So that's it for now. If there's anything else that you can think of, you add it. Oh, I should also talk about real quick, because this is a review of vertex form. I have my vertex form here. I tell myself that A tells me the opening and the width. I'm not redoing what I already know, okay? But it gives the vertex. That's important about the vertex form. It gives me the vertex. That negative tells me that I changed I tried to go OG here. I know it doesn't look like OG, but changes the original sign. I give myself an example where I have +4, +5, and then the plus turns into negative, so that's something to observe, but the 5 is there. Then I also tell myself that if A and K have the same sign, no intercepts. If they have different signs, 2 x-intercepts. If K is equal to 0, it has exactly 1 x-intercept. It's on the x-axis. You know what? I'm just now I think of, that's when the vertex is the x-intercept as well. Okay? So the scanned version doesn't have all the highlighting. Okay, I'm telling you already. But I hope this helps. Free of charge. Like and subscribe. That's all I can ask. Right?